solutions did it a different way.
Yeah, solutions are weird. Alright. Alright guys, ready? Let's go over this. Proof for see the way it's n equals n. They're natural numbers, so what's the very first one you need to do? 1. So proof for n equals 1. And you go 1 plus 2x to the power of 1 is greater than or equal to 1 plus 2 times 1 to the power of x. They're actually equal to each other this time, aren't they? They're equal to each other, right? So what's that mean? True for n equals 1. Happy days, alright? Now we're moving on to the next one, which is part 2. Anybody taking down part 1, it means you didn't try. No offense. And anybody taking down part 2, that also means you didn't try. Really?
As soon as I saw the X, I was like, no.
Really? You just won't even write down this stuff?
No.
Okay.
I was feeling lazy last night.
It actually wasn't even that. They cancel each other out this time.
Alright.
Make them back if they live.
Oh look, that was so difficult to pass that question. Too much strain. Alright lads, on to part 3, which is where you should probably end up taking stuff down, alright? So, what we're going for is prove for n equals k plus 1. Happy days. And you scroll down. And you go, okay, what am I going to do here? Alright, I'm going to say that it's 1 plus 2x to the power of k plus 1. I'm also going to say it's 1 plus 2 times k plus 1 times x. And that's going to be greater than or equal to 1 plus, 2kx and 2x. Alright with you guys? If you imagine the x is with the 2, 2x times k, 2x times 1. It's a bit easier, okay? Now, this part here, what's the golden rule? Make it look like step 2 so you can use step 2. So I'm going to separate this out into 1 plus 2x to the power of k and 1 plus 2x. Now, remember what we said earlier, right? I'm going to use my colours again. Yellow number is bigger than blue number. Happy days? There's the yellow number. Any number multiplied by the yellow number is bigger than the same number multiplied by the blue number. Okay? So what I'm basically saying in a weird way is 4 times 3 is greater than 4 times 2. Because 3 is bigger than 2. That's essentially what I'm saying. Alright? Just with colours instead. So, what we're going to do here is we're going to say 1 plus 2x to the power k multiplied by 1 plus 2k is greater than or equal to the blue number. So see the way I'm changing the yellow? I'm changing this yellow number and I'm putting in the blue number instead. Alright? And that's where it all comes to life. So what's that? Plus it's the blue number, which is plus 2kx. Okay? And would everybody agree with that statement? Because it's assumed true by part 2, isn't it? And in turn, if I can prove that this smaller number is bigger than this, then I'm in business. Okay? Because the larger number must be bigger than both of them then, which is great. Okay? So now I'm at this level here. Okay, that makes sense, right? So, I do have to explain what I did there. So that's good news. So what do you say? Assume true by that 1 plus 2x to the power k is bigger than or equal to 1 plus 2x. It's good to put that little mini explanation down there, okay?
2kx.
Oh, 2kx is it?
Yeah.
Thanks. Right. Now I'm just going to multiply this out. I'm going to get 1 plus, what is it? 1 plus 2x. And then I'm going to get 2kx And then 2kx squared, is it?
4K.
Sorry, 4kx squared, thank you. And we're just going to do a bit of cancelling. Bit of cancelling, love it. I'm all about that life. Now, the two of them cancel, yeah? Two of them cancel. Hell, the ones cancel. And that makes life really easy for me, doesn't it?
Yeah.
Because what can we say about x squared?
X has to be greater than 0.
Guaranteed positive number. Perfect square, yeah? And what can we say about 4k? K is an element of n, which means has to be positive. Everybody cool with that? Alright, I'm just going to call this out because I hate writing it. Wait. Here's what we're going to do next. Alright, is everybody happy that true for n equals k plus 1 if n equals k is true, hence true for all values of n, element n. Happy days. Number 7. I think is this going to work nearly exactly the same?
Yeah.
Alright, we'll do it anyway. Proof for n equals 1. So what do we get? 1 plus ax to the power 1 greater than or equal to 1 plus a times 1 times x. 1 plus ax greater or equal to 1 plus ax. Therefore, true for n equals 1. Okay. Part 2. Assume true for n equals k. And what we get is 1 plus ax to the power k greater or equal to 1 plus akx for a greater than 0, x greater than 0, k element n. It's very cheap just rewriting the question, but get you 5 marks. Now, question 3, or part 3. Prove for n equals k plus 1. And exactly like the last question, alright, so what do I do here? I need to make part 2 using part 3, so how do I separate it out? 1 plus ak to the power of k and 1 plus ax to the power of 1 greater than or equal to 1 plus akx plus ax. Alright, now what we said earlier was, once again, just done by colours. Yellow number is assumed bigger than the blue number. This means that any number multiplied by the yellow number should be bigger than the same number multiplied by the blue number. Okay? So that's what we're assuming. So we're going to say 1 plus ax to the power k by 1 plus ax. That has to be bigger than or equal to, or it's assumed bigger than or equal to, what's that? 1 plus akx, is that right? Times 1 plus ax. Oh no, you don't. And that's greater than or equal to 1 plus akx plus ax. Now what do I need to write down to sort of make sure I get everything I want from the marking end of things? What have I left out that the marker could take marks off me for?
Assume true by n equals.
Yeah, I didn't explain my substitution there, okay? I didn't explain the triple inequality. So you might want to just underline it, like so. And this is assume true by n equals k, that 1 plus ax to the power of k is greater than or equal to 1 plus akx. Happy days, right? Now we're firmly on the blue part now. If I can prove that the left side is bigger than the right side, well, that means that this one over here is definitely bigger than the one over there. Okay? So here's what we're going to do. We're going to multiply that out. And we're going to get 1 plus ax plus akx plus, what's it, a squared k x squared?
Yeah.
Greater than or equal to 1 plus. Love me a bit of cancelling. So now you don't actually really. It's a good idea not to show the cancel in an exam sometimes. Because sometimes you strike out something and sometimes the examiner might not be able to read it. So if you are striking out, just do it lightly. Okay? And so we know we're cancelling them, don't we? And what do we have left over then? Just that, isn't it? And how can I prove that this is definitely bigger than 0? So I could rewrite it as the following. Could I write it as ax 2b squared times k? Would that make sense? You don't have to do that, but I think that makes sense. Positive because it's a perfect square. Assume you get from x to the same to square. And positive because as k is an element of n. Hence, by the principle of mathematics, true for n equals k plus 1 if n equals k is true. Hence, by the principle of mathematical induction, it's true for all n element to n. The end.